Okay.
So now, yes, just mute yourself. Hello.
Okay. Just.
Hello.
Okay. Yes.
Okay, I just mute. Hello. My echo is coming.
Let me try.
Yeah, I think. You just stop in the Google Meet, so the voice will be automatically. You just mute yourself in Google Meet. Yeah. Now I think voice is clear. Yeah. Now is audible for everyone.
Yes, it is audible.
Thank you, sir. So this is the pvsyst software. So I have a licensed version. This is a 7.0. So here is the different criteria like the grid connected, standalone, pumping, database, tools, and measure data. So first we go to the grid connected system. So when you click the grid connected system, so you have find out to this type of icon in your screen. So this type of icon will be common on the screen. So here is the first step is the project data. So suppose that we want to make a 100 kilowatt of project. So what we do it, we just go there and click here, the 100 kilowatt peak solar power plant. Okay. After doing this thing, you just go to this option. This is the choose the site. So first you click this particular icon, just choose the site. So we just select this icon. And once we click this icon, we have gotten the different type of option. So from here, the India is already there. So we take the India. And once you take the India, we just decided to the location. So suppose that we want to install the system in the Delhi. So we just click in a Delhi location. And after clicking the Delhi location, we click the OK button. My voice is not coming? No voice, sir. Not audible, sir.
No, it's coming, sir. Their device setting maybe not proper or anything.
Voice is clear. So somebody has tell me the no voice, sir.
Hey, voice is coming clear. He might be having some issue with his network. So, but for us, it is clear.
Yeah. Sir, we will also take the northeast location. First, I give the example. So I give the northeast location also.
Okay, sir.
I think somebody has written no voice is there actually.
You might have issue with might have open with their desktop. So desktop there is a compatible issue with this one, maybe headphone and
yeah, there is one audio setting they have to do. Actually, I was facing the same problem. They have to select call in the internet actually.
Yeah, call in the internet. Yes, you just do the call.
Yeah,
in the internet.
Just go to the audio setting and call in the internet. You have to select. You will get the. I was having the same problem.
Yeah, now is okay actually because I think you did not aware about the Zoom application, so that's why sometimes the problem is happening. So there's the first step. We go to the project data. We go to the project name. And then we go to the metronome site. So we just selected from this location. We select from the India. So we type the I. So we select the India. Now the India, we take the Delhi. So we just click the Delhi location and click the OK button. Now, after doing this thing, you just go to the save the option. So once you save the project, so it will be tell you that particular view. So I just make this 100 kilowatt for the Delhi location. Now, after doing this thing, the next step will be coming there. So the next step is the orientation. So now how can I do the orientation? So this is option is given there for the orientation. I click this orientation option. So once you click the orientation option, this is the default value is there. So this is the 30 degrees, the default value is there. But before that, we understand how can we got the latitude, longitude, and altitude. So can you see this option? This is the view option. If you click this particular view option, this icon will be open, and when this icon is open, so it will be tell you in a Delhi subdivision is the latitude is a 28 degree, longitude is a 77 degree, the altitude is a 212 meter, and the time zone is a 5.5 hours. So from here we can find out the latitude of that particular location. Now I click close this particular object. Now again we go to the orientation. Now first thing, we just give the system is a 28 degree. So we just put my module in a 28 degree. Now in a same pace, we have a three different the criteria. One is for the summer month, one is for the winter month, and one is for the yearly radiation. So now we first go to the summer point. If you're putting my module in a 28 degree and go to the summer month, my loss is minus 1.7%. So now they tell me to the participant, in a summer time, we decrease the angle or increase the angle? In a summer month, we increase
the angle by 15 degree.
No, in a summer month.
No, sorry. Decrease the angle by 15 degree.
Yeah, so decrease the angle of the 15 degree. So now if I in decreasing this angle, so suppose that I decreasing this angle, so now you can find out this loss parameter is automatically come down. So if I doing around 14 degree or 15 degrees, so it will become around 0.0%. But if the same thing will become in a yearly basis, so my losses will become around 3.7%. Okay, so this is the things if I putting is not proper latitude angle. And similarly, when we're talking about the winter month, so once I click the winter scenario, so when I click the winter month, my losses will be happening around minus 3.1%. Okay, so in this case, what will we do? You just increase the tilt angle. So if my tilt angle will become around 43 or 44 degree, my losses will be minimized in that particular case. So as a good designer, whenever you design the solar power plant with the help of the pvsyst, you always design in a yearly radiation basis. So first criteria, you click in the yearly radiation, and then after you decide the tilt angle. So there the tilt angle is a 28 degrees. So we just put the 28 degree and the yearly irradiation value. Now after doing this thing, you just click the OK button. Now, after clicking the OK button, there will be define the system. So now my system icon is there. I just click this particular icon. I click this system icon. Now, after clicking this system icon, you have seen this particular ID. Now you can find out the value. The first thing in your mind. So now we just take the power plant capacity. So this is the 100 kilowatt of power plant. So we just put the value is the 100 kilowatt. So first thing we just give to the capacity. This is the 100 kilowatt of solar power plant. After doing this thing, we go to the selection of module. So how can you select the module? So this is the area. From there, you can select the module. So this is the different module company name is here. You can take any company module from here. And if the data is not there, so if you have a PAN file or something, so we can also export that particular data. So suppose that I again take the Trina Solar module. And if you want to the Tata Power module, so you the Tata Power and only the 3 type of module is there. So you can also cross check of that module. But now we just take the Trina. So I just type the T and then I type the Trina Solar. After when you select the company name, So this is the particular icon. You can find out to the different wattage of the module. So from this window, you can find out the capacity, then the technology, then the model name, then when the module are made it, then also you can find out the manufacturers and other things. So this is the criteria. So suppose that for the 100 kilowatt of system, if I want to take the 250 watt module, how many module is required there? Can anybody tell me? If I using to the 100 kilowatt of system, and if I taking the 250 watt module, so how many module we can choose from that particular case? Please write your answer in a chat box.
400.
Yes, so when I click the 250, so it is automatically give the 400. Okay. Similarly, if the same power plant, if we are using the 300 watt module, so it will be automatically give the 333. So this is the compatibility kind of thing. So if you select to the one number of the wattage of the module, is automatically distributed to the system. Okay. Now you can find out from here. So you just go from this particular place. I again select the 250 watt module. So now we have the 400 module. After doing this thing, my system will be selected. Now I go to the selection of inverter. So here the option is the selection of inverter. So suppose that I need the different company, so I can also take any one company from here. So in ABB is a good inverter, so I just go to the ABB, and from there ABB we can also do the same thing. So in this designing, we can take the different type of configuration. Either we can use the 10 kVA of 10 inverter, the 50 kVA of 2 inverter, 25 kVA of 4 inverter, or 100 kVA of 1 inverter. So in this system, if I doing the design of 100 kilowatt of system, so in this case, I am taking the two different inverter of 50 kVA. So I just go to the 50 kVA option. So this is a 50 kVA option. I just select the 50 kVA. So now in this way, it will be automatically selected to the inverter. So here is the system is 100 kilowatt. The number of module is the 400. The number of inverter is around the 50 number of 2. Now this is a 400 module. Now you can find out this is the number of module in a series. So there is a 20 module in a series, 20 module in a parallel, and the total the capacity of the power plant will be around the 400. Okay. After doing this thing, you just click the OK button. So now you can see that this is the Trina solar module. This is the number of module in the series, number of module in the parallel, and this is the inverter. So you have required the 250 kilowatt of inverter, and they are the connected to the single string. After doing this thing, you click the OK button. Okay. Now we come to the detailed loss part.
Sorry to interrupt, sir.
Yeah. Yeah,
particular screen. Just before that, sir, the earlier screen.
Earlier screen, okay, yeah.
Inverted thing.
Yeah.
Yes, sir. Sir, instead of selecting the kilowatt peak kilowatt, if we go for the area of the module, in that case, how can we do the selection of the inverter if we do not know exactly how much will be the kilowatt peak?
Yeah, so this is the area. So there is a two options. This is the area. If you're putting the area, so it will become to the particular region. If you know the load, so it will become here. So if you know,
suppose I know only the area. I do not know how much means it will be coming kilowatt in terms of kilowatt peak. I do not have any idea. So how will I go for selection of the inverter? That is the question.
Yeah, similar thing. You just go to from this particular place, the area. You put the area, and then after when you go to the selection of module and module, so it will be automatically tell you how much the capacity is there.
Okay, so when we type, okay. Sir, can you please type some other number, random number, instead of 655 there?
655 is come from the 100 kilowatt. So
I just want to check.
To the 50 kilowatt.
Okay.
So now you can see that this area is automatically.
Okay, got it. That means if I type some other area, then automatically will take kilowatt peak, right?
Yeah, similarly, because I already take this particular area.
Got it, sir.
Automatically
Thanks.
converted this thing.
Thanks.
And how do we select this combination of watt and voltage for a panel, for a module?
Means?
Like we have selected here 250 watt, 26
Yeah.
volt. How do we select this combination, the 250 watt and 26 volt?
Yeah, this is the available of the module in the market actually. This is the available of the market. So if you want to take
all are on the same voltage. All are on the 26 volt.
Yeah, maximum is a 26. So if you go to the different type of capacity,
like we have got 30 also, we have got 31 also, we have got 32 also.
Yeah, but this is the capacity will be changed, no, sir?
So the combinations are fixed by the company. So you have to select out of that.
Yeah, it's select from out of that. Yes, you can.
But this voltage may be depending upon the area also. That how much voltage you can generate there?
No, voltage is not depend to the area. So this is the voltage will be taken on the 60 degrees centigrade, means 25.9. But now if you see this module, so this 25 watt module, the voltage, the VOC is 38 volt. This is not the 26. So this 26
correct.
is taken by from the 60 degree, means if
this
the
will be as per curve. This will be as per curve.
Yeah, this is for the curve. So if you go to the graph, so you can find out this type of criteria. So this is the radiation. Now I just
understood.
Thing. So I just
show you the doubt was that, like, company, are they manufacturing as per requirement of that particular area?
No,
that how much radiance is there, how much temperature persists at that place?
Yeah, so this is the graph. So this is the 10 degrees centigrade. Your wattage is 265. If you go to the 25, so this is go to the STC condition 250. If you go beyond the 40 degree, again the wattage will be reducing. So you can find out this type of things is there actually.
Thank you.
So this is the criteria. The 26 means is the 60 degrees centigrade and minus 10 is means the maximum optimum case. But this module, the VOC is come around 38.00 volt. Okay, now after doing this thing.
Sir, is it possible to check a fill factor of that particular module we have selected?
Yeah, you can do it. Now you can do it. You just tell me how much the fill factor. Now you have a ISC is 8.79. You just note down. This is a good question.
Okay. We can multiply and divide it. Yeah, BSc and BOC and the ISC.
Yeah.
8.79. Yeah.
Yeah. So please note down the value. I just tell you. The ISC of the module is 8.79. The VOC of the module is 38.00. The IMP of the module is 8.251. And the VMP of the module is 30.30. Can you calculate the fill factor?
Yes, we can do that.
Fill factor and write the answer in a chat box.
Okay,
give 1 minute time to everyone. Please calculate it.
What is the reason that fill factor is not printed by the manufacturer itself? Because such an important part.
Yeah, I don't know, but in a data sheet,
is there any commercial angle into that?
Pardon?
Is there any commercial angle into that?
Not the commercial angle, but generally they did not represent because you have the formula and you can easily calculate the fill factor. So that's why they have no require such kind of thing actually. Are you getting this point? Yeah, what is the answer?
74% it is coming. 0.074. 0.74. 0.74.
Yeah, so that is the thing actually. That is the thing. So with the help of that, you can find out now this fill factor is a 0.7, more than 0.7 means it will be the better technology. So you can use of that kind of thing. But if it is not coming to the proper way or beyond the limit, so you did not use such type of module. So this is just the selection criteria of the system actually. Everyone is getting the value of fill factor. The formula of fill factor is IMP into VMP divided by ISC into VOC. And if you're doing the same thing, if your value will become around 0.7 to 0.9 means your module quality is the best quality of module. Now we just.
But there is no cost factor into this. Like, there are so many modules available. with different fill factors and different voltages and different wattages.
Mhm.
Now, once till we know the cost factor about all these, the selection will be very difficult because that is one of the major part of that.
No, the
Major part of the
selection
size.
of the cost is the latter stage, because in the selection of the module, I will tell you for how can you select the module price. We just keep so give me some time, so I will give a one site from where you can got the cost of the prices. But in this software, the parallelly you cannot do the costing. In any software in the world, in the parallelly you never ever do the costing is there. The costing is already done at the end of the simulation or before the simulation. But parallelly you cannot give the cost and other thing is there actually. Can I go ahead?
Yes, please.
Yeah. Now, after doing this thing, you just click the OK button. Now, there is a detail loss option. So initially, I did not take any losses from my side. So I did not do anything. Now, again, we go to the shading part. So here, I did not want to do any shading kind of thing. Now we go to the run simulation. So we already done the project data, the orientation system and other thing. Now I just go to the run simulation. So once I click the run simulation, so my project will be running is there. So it will be take some 1 and 2 minute time. So now my project will be running here. Okay. Now I just go to clicking the report option. So when I click the report option, so this particular icon will be open here. So this is the pvsyst version 7.0.11. The today date is 20/11/20, and this is the 4-page report. So my project is a 100 kilowatt of solar power plant. That is for the Delhi subdivision. That's the latitude, longitude, the altitude, time zone, and the other parameter is there. Similarly, the simulation date and the timing. So now the timing is 12 hour 18 minutes. So this simulation date is here. Now this is the tilt angle is a 28 degree. The azimuth is 0 degree. And now we come to the characteristic of the module. So here the model. So this is the Trina Solar, the 20 module in a series, 20 module in parallel. The 250 watt peak module, the 400 module is required. The total capacity is the 100 kilowatt. Similarly, we take the inverter. So we take the 50 kilowatt of 2 inverter. So total the capacity will become is a 100 kilowatt. Now, this is the important part in the page number 2. So please note down this 3 value. Please note down this 3 value. This is the energy production is 180.8 megawatt hour in per year. The specific production is here. It will be taken around 1808, and the performance ratio is around 18.74. So please note down this value, because this value is coming. We did not consider any losses from our end. So that's why the value will be coming this much. Now, after doing this thing, we go to the again the losses parameter, and then we will find out how much the variation will be coming there. Now you can see that the performance ratio value is 18.74. So this is the good performance ratio for the solar power plant. If you go to the bottom side, so this is the data from the global horizontal, diffuse horizontal, T ambient, global horizontal, E array, E grid, and the performance ratio behavior is there. Now in the page number 3, so this is the curve of the daily input output diagram and the other variation. And now you can find out to the losses. So this loss diagram will be taken from the internal value. Here is no any swine losses and other losses. Now we give to the losses from our end. So I just close this the system. And again, we go to the loss parameter. So we just go to the detailed loss parameter. We just go to the detailed loss parameter, and then we just decided 2 things. So first thing, we have the thermal parameter. So in thermal parameter, we have 3 different choices. The first choice is the free mounted with air duct behind. So if you have using to the one single array of the system, so on that particular case, you have using the free mounted module system. If there is the semi-integrated means if there is a different type of array combination is air, so that the condition you will using to the semi-integrated air duct behind. And the third option are using to the fully insulated kind of thing. So those location where is like the warehouse is cold storage, there is a no air duct behind from the backside. So that type of condition you have using to integrate it with the fully insulated back condition. So now in a majorly places we have using the semi-integrated with air duct behind option. So we just click this particular option. Now we come to the next option. This is the ohmic losses. So from ohmic losses, we go to the default value kind of thing. So we give to the default value is here. Then we go to the module quality and other thing. So now we will give to the LID losses. So it will become around 2% kind of thing. Now we come to the swelling losses. So it will become around the 3% the scenario. Then we so it will be all automatically you define to the monthly basis. So January, February, and till of the December, how much losses will become there. Then this is the IM losses. So this is called to the incidence angle modifier losses of the system. Then we have the auxiliary losses. So if there is some fan, some light or something is there, so with the help of that, you can also decide it to this losses. Now we come to the aging factor. So suppose that sometime the people are needed to the 25-year data generation. So from here, you can define the 25-year generation, how much energy generation will be happening in the 25 years. If you putting the 10 years, so how much energy generation will be happening in a 10th year. And if you're putting in a first year, so it will be give to the how much energy generation in the first year. So this is the simulation. So if you did not using anything, so it will be give to the normal behavior. But if you want to the particular year, suppose that in a 10th year or 20 year or 25 year, some value, so it will be give to the proper value is there. Okay. Now, after doing this thing, you go to the unavailability. So in unavailability, it is so the how many times your system will be the shutdown, like the quarterly basis, how many hours it will be shut down. Then we have the spectral relation. So we did not change from the spectral relation. Now, after doing this thing, we just click the OK button, and again we go to the run simulation. Now we find out in the run simulation there is some the value will be decreases. Now we will find out to see the initial value, and after doing to the losses, how much effect will be happening there. So now we come to the report part. And in the report part, we just go to the second page. Now, can you note down the value? Can you compare the earlier value and now value? The produced energy is 180 or something. The specific production is 1808, and the performance ratio is 18.08. Now, after doing the losses, this performance ratio behavior will be changed from here. So this is the criteria. With the help of such kind of thing, we can change the value of the system. Similarly, if you go to the loss diagram, so you can find out this is the losses due to the temperature, the module quality we already taken here. So the LID losses, we taking the 2%, the mismatch losses is already there. And this is the swelling losses, it is automatically come is there. So with the help of that, we can define to the different type of the losses, and then we will give to the report to your customer. If you want to convert this report, so you just click in a save as a PDF. So when you click the save as a PDF, so this will be converted in a PDF form of the report, and then after you submit to your client. So this is the basic criteria for the using of the pvsyst software, and with the help of that, you can design your solar power plant. Okay, are you getting this some idea about this thing?